Welcome to Knowledge Hub. Today we're exploring the innovative and challenging topic: how can we build landing and launch pads on the moon? As we look toward establishing a sustained human presence on the moon, building landing and launch pads becomes crucial. These structures are essential for ensuring safe landings, protecting equipment from lunar dust, and facilitating future space missions. Lunar regolith. The moon's surface is covered in a fine, abrasive dust called regolith. During landings, this dust can be kicked up by the rocket's exhaust, posing risks to both equipment and astronauts. A well-designed landing pad can minimize this issue by stabilizing the surface and reducing dust clouds. Lack of atmosphere. The moon's lack of atmosphere means that any construction will be exposed to harsh conditions, including extreme temperature variations, micrometeorite impacts, and radiation. Materials used must be durable and capable of withstanding these challenges. Proposed construction techniques. One of the most promising techniques is using 3D printing technology with lunar regolith as the raw material. This approach reduces the need to transport building materials from Earth, making the process more cost-effective and sustainable. Robots or autonomous rovers could gather regolith and use it to print landing pads layer by layer. Sintering involves heating the lunar regolith until it fuses into a solid, brick-like material. By using concentrated sunlight or microwave beams, we could create a stable surface that can withstand the force of a rocket landing. Another concept is creating lunar concrete using a mixture of regolith and a binding agent, possibly brought from Earth or synthesized on the moon. This concrete could be used to construct more permanent and durable landing pads. Implementation strategies. Before humans set foot on the moon again, robotic missions could be sent to construct landing pads. These robots would carry out the 3D printing or sintering processes autonomously, preparing the site for future human missions. Building modular landing pads that can be expanded or adapted over time is another strategy. Initial modules might be small, but as missions continue, additional modules could be added to accommodate larger landers and more frequent missions. Benefits of lunar landing pads. A well-constructed landing pad provides a stable surface for spacecraft, reducing the risk of accidents during landings and takeoffs. It also protects surrounding equipment from the damage that could be caused by flying regolith. Establishing landing and launch pads is a foundational step toward building a sustainable lunar base. These pads could serve as hubs for future missions, making lunar exploration more efficient and enabling more complex operations on the moon. Conclusion: building landing and launch pads on the moon is a key step in making lunar exploration safer and more sustainable. Through innovative techniques like 3D printing, sintering, and using lunar resources, we can lay the groundwork for a long-term human presence on the moon. Thank you for joining us on Knowledge Hub. Stay tuned for more insights into the future of space exploration. Don't forget to like, subscribe, and hit the notification bell for more fascinating content.